Hello, my team is conformed by Lisette Ayala Flores, Cristian García García, Jessica Gardeño Álvarez, Daniela Abril Hernández Martínez, and Cynthia Piña Remigio. And the topic we chose is about separable equations, so we're gonna start talk about it. This type of equation are characterized in that we can separate the variables, that is, we can leave out the expression that involve a variable on one side of the equation and all the expression that involve the other variable on the other side of the equation. So we will say that a differential equation is of separable variable if it expressed in the following way, that is dy between gx equal to g multiplied by x h multiplied by y. So how can you tell if an equation is separable? Well, the most common class are equations where dy between dx is equal to a product of a quantifier of f dy and g dx.
For example, the number 1. Let's consider the equation 2x to the power of 6y más 9x raised to the power of y equals to 0. The first thing we have to do is rewrite as equation of difference dy on dx. In this way, we write the equation as follows: 2x power of dy on dx más 9x raised to the power of y equals to 0. We will work with the differences of x and y as it is, whereas factors in the y we can separate the variables of follows: 2x to the power of 6y dy on dx más 9x raised to the power of y equals to 0. 2x to the power of 6 dy on dx equal negative 9 raised to the power of y to the power 2x to the dy equal negative 9x raised to the power of y to the power dx. dy on dy equals negative 9 dx on 2x to the power of 6. We notice that our expressions involving are on the left side of the equation and high expression involving x are on the right side of the equation. So the next thing we will do is integrate both sides of the equation. Integrate dy on y equals integrate negative 9 raised to the power of y dx on 2.
Two constants from two different families of antiderivatives, however, both are grouped in the constancy on the right side of the equation. Once the integrals have been calculated, we proceed to isolate the variable and to obtain the equation we are looking for. Menos 1 sobre 3xy cúbica igual a 9x cúbica menos sobre 6 más c. 1 sobre 3y cúbica igual a menos 3x cúbica sobre 2 más c. 3y cúbica igual a 1 sobre 3 medios de x cúbica más c, y cúbica más 1 sobre 3 medios de x cúbica más c, y es igual a raíz cúbica de 1 sobre 9 medios de x cúbica más c. In the separable differential equation, y es igual a 1 más x más y cuadrada más xy cuadrada, you can factor the right hand side to get de y sobre dx es igual a 1 más x más y cuadrada por 1 más x, quedando de y sobre dx igual a 1 más x por 1 más y cuadrada. Separating variables, dy sobre 1 más y cuadrada igual a 1 más x de x, integrating dy sobre 1 más y cuadrada igual a la integral de 1 más x de x, quedando como tangente inversa de y igual a x más x sobre 2 más c. Por lo tanto, y es igual a tangente de x más x sobre 2 más.
Example 3. 2y dy plus I minus 3x dy equals 0. Solution. Separating variables 2y dy plus I minus 3x dy equals 0 happens to be 2I 3x dx plus dy divided by y equals 0. Integrating each term of the equation, integral of dy divided by y plus integral of 2I 3x dx equals c1. Int y plus 2 divided by 3 I 3x equals 0 happens to be 3 int y plus 2I 3x equals 3c1. Result 3 int y plus 2I 3x equals c. Example 4. Weigh in 4xy plus 4 dx plus x in 4xy plus 4 dy equals 0. The equation is going to be factored unit. We are left with a mode managed expression. Y for in 4xy plus 4 plus x y dx plus x in 4xy plus 4 dy equals 0. So we are left factoring. Now we don't change our variables. Xy equals cy equals t divided by x happen to be dy equals x dt minus t dx divided by 2x2. Simplifying the equation, now multiplying the entire expression. T for n for t plus 4 plus t dx plus int for t plus 4 for x dt minus t dx equals 0, reducing and grouping the variables which their corresponding differentials we finally have.
Integrate both equations. Integral 1 over x dx more integral ln parentheses t more 4 over t high 2 dt equals 0. The first integral is simple, with which its solution is integral 1 over x dx equal ln parentheses x. The second integral is an integral by parts where we have integral ln parentheses t more 4 over t high 2 dt equals 0. Integral ln parentheses t more 4 over t high 2 dt equals 0, or u equal ln parentheses t more 4 du equals 1 over t more 4 dt. Du equals 1 over t high 2 dt. V equals less 1 over t. Integrate both equations. Integral 1 over x dx more integral ln parentheses t more 4 over t high 2 dt equals 0. The first integral is simple, with which its solution is integral 1 over x dx equal ln parentheses x. The second integral is an integral by parts where we have integral ln parentheses t more 4 over t high 2 dt equals 0. Integral ln parentheses t more 4 over t high 2 dt equals 0, or u equal ln parentheses t more 4 du equals 1 over t more 4 dt. Du equals 1 over
t high 2 dt v equals less 1 over t